Okay, so number one, through 3, we're doing matching. And number 1, I see 1's congruent to 2, 2's congruent to 3. There's that common piece. And so then they conclude that 1, and they skip over 2, and it's congruent to 3. That's transitive property, which is C. Number 2, if angle ABC is congruent to angle DEF, and then DEF is congruent to angle ABC, they switch the left and the right side. That's symmetric property. And then number 3, they're saying the same thing is congruent to itself. That's the reflexive property of congruence. Down here we're going to solve this. So we're going to probably distribute this 3. So we are allowed to do that because of the distributive property of equality. Next, I'd probably add the 2x to both sides, leaving me with an 8x minus 15 on the left side, and 17 on the right side, and that was the addition POE. Then I can add 15 to both sides, leaving me with 8x equals 32. That's addition POE. Then I can divide both sides by 8, giving me x equals 4. That was the division POE. Alright, then we take a look at number 5. They don't give us a reason for the first step, and it's not listed in our givens, but if we look at the picture, we see that AC is 13. It shows it in the picture. Also shows that BC equals 3. Since they show those in the picture, those are given. It's okay to go ahead and write given. It's because of the picture. It's because of the diagram. Next, AC, that full segment, is equal to the pieces AB plus BC. That's segment addition postulate. That was from last chapter. We use segment addition postulate, and a lot of times they come in pairs. I think we actually see it one other time in this proof. And you'll notice that the one side is the entire segment length, AC. The other side is 2 small pieces. That's what segment addition postulate will usually look like. Then it asks to do substitution, so I'm going to plug numbers into that equation that we just had. The first statement says AC is 13, so I can replace the AC with 13. I can't replace AB with anything, so I leave it as AB. BC, we know from above, is equal to 3, so we can substitute 3 in there. Then I want to solve for AB, so to do that, if I subtracted 3 from both sides, I would get AB on the right side equals 10 on the other side. They switch sides here, but that's what this statement's saying. So that was the subtraction POE. Next it says to use our given. So we go up over by the picture. There's 2 things that were given to us. AB is congruent to FG, and AC is congruent to EG. We just need to list both of those. So fit them both on that same line. Segment AB is congruent to segment FG, and segment AC is congruent to segment EC. Then it tells us that FG is equal to 10. Let's stop right there. We previously said 10 2 lines above with AB, but in the last line we said that AB is congruent to FG. So all we've done is we've replaced the AB with FG to say FG equals 10. So that's substitution. Additionally, they're saying EG equals 13. We had 13 way up in the first line. That is equal to AC, and we just said that AC is congruent to EC, so we could substitute EC into AC. So I would say substitution. POE. I would also accept transitive. Now we've got EG, which is the full segment, is equal to EF plus FG, the 2 small parts. There's our other segment addition postulate. And then once again, they replaced EG with 13, but we said EG was equal to 13. They replaced the FG with 10. We said that it was equal to 10. So that was simply substitution. POE. It doesn't give us any clue on the last step, except it does tell us at the beginning of the problem what our goal is. We're trying to prove that EF equals 3, so that better be our last statement, that EF equals 3. How do we get that from the previous statement? Well, it looks like we have to subtract 10 from both sides to get EF by itself. And so that would be the subtraction. POE. Alright, let's go to the back page. Number 1, AL is equal to SK, that's a given. Number 2 is a little tricky. They tell us we're using reflexive, but reflexive is when something equals itself. So what is it that we're taking a look at? Well, the goal, you have to know a little bit about the goal. The next step, step 3, looks like we're adding LS to both sides. We kept AL on the left side, we kept SK on the right side. We are adding LS to both sides, so that's actually in step 3. If I jump ahead, is going to be the addition, POE. But what I added to both sides was LS, so that's what they were looking for in line 2, that LS equals LS. That way I can say that I'm adding the same thing, same value to both sides. Let's jump ahead to number 4 then. AL plus LS, look at the picture, AL plus LS is equal to the entire length from A to S. Oh, well, that's segment addition postulate. You see that that shows up in the 5th line too, but I told you that a lot of times it's going to happen in pairs. And so yeah, they're saying that SK plus LS is equal to LK, segment addition postulate. So then in step number 6, what we're doing is we're combining lines 3, 4, and 5. If you look at line 3, it starts off with AL plus LS. But in step 4, we also had an AL plus LS. We said it was equal to AS. So what we can do is take the AS and substitute it in on the left side. Then on the right side, we have SK plus LS. In number 5, we have SK plus LS equals LK. So we can take LK and substitute it into the right side, giving us AS on the left side, LK on the right side. I know what my goal is. They told me up above to prove that AS is equal to LK. I just got that, and I did it through substitution. POE. I'd also probably accept transitive, but I like substitution better in that case. Okay, number 7, just a heads up. They show that we're going to do it in 4 steps. We are not going to do this in 4 steps, so we'll have a little bit of work to add in between. I'm not a real big fan of this problem because of that. But number 1, that's a given. Angle 1 and looks like angle 2 are a linear pair. Angle 3 and angle 4 are a linear pair. I would once again say given for both of those because it is given to us in the picture. So it's part of the diagram. And then number 3, that I want us to apply the linear pair postulate. Well, the linear pair postulate says, oh, actually we can do this in 4 steps. I was wrong. We can do this. The linear pair postulate says that if they're a linear pair, then they're supplementary. So we could say that angle 1 and angle 2 are supplementary. We are going to need one more step in line 4, before line 4. So, sorry, let me go back. 1 and 2 are supplementary. And then we can say 3 and 4 are supplementary. And okay. So I cannot yet say line step 4. I'm going to cross that out. We'll get back to that. I have to do some work first. We said previously that 1 and 4 are congruent. So I will be able to replace 1 or 4 with the other one from line 3. So maybe I'll say line 4, or angle 4 and angle 2 are supplementary. I'm really skipping a step because I should have technically made an equation before I substituted in, because I'm really using substitution and I shouldn't do that unless it's already an equation, but we'll go ahead and sneak it in there. Now what I'm looking at are that 3 and 4 are supplementary, 4 and 2 are supplementary. 4 shows up in both of those cases. So we could say that 3 is supplementary to 4, 2 is supplementary to 4, and we had in that last section what's called the congruent supplements theorem, that if 2 angles are supplementary to the same thing, then they're congruent to each other. I can say that angle 2 is congruent to angle 3 for that reason. The congruent supplements theorem. There we go.